These are your first notes for this week, notes number 22. We are moving on to section 7-4 in the book, page 447, and these are about angles of elevation and depression. Make sure you've got your name, date, period, and you should already have this warm-up completed from during class. So here's our essential question. How do I use angles of elevation and depression to solve problems? Remember that that's the essential question you'll be answering in your summary, and also make sure you've got your 3 questions on the left of every page of notes, and like I said, the summary at the end. All right, so what we're going to do first is we're going to see book page 447 before we start writing this down. So I'm going to go ahead and show my book. Feel free to look in yours. So this is page 447. 447, so you can see. Okay, so I like this part in the book, and rather than having you copy all of it, I figured we can just look in the book. So it says, don't worry about that first part. Suppose a person on the ground, they're looking up and they see a hang glider at a 38 degree angle above the horizontal line. So we're looking at this person right here. They look up and they see that person in a hang glider. The horizontal line is parallel with the ground, and it's also parallel with this horizontal line. So it's just like straight across from their eyes. And it says, this angle is the angle of elevation. So from the eyes looking up, and then the angle formed with the horizontal line, going straight across from the eyes. Okay, that's angle of elevation. At the same time, the person on the hang glider sees the person on the ground. So if you're looking from the point of view of the hang glider, they're looking down. Their gaze would be looking down, but they also have a horizontal line straight across from them. So at the same time, the person on the hang glider sees the person on the ground at a 38 degree angle below the horizontal line. This is the angle of depression. So an angle of depression, the key is below. It's an angle that goes below. And the angle of elevation is an angle like if you're looking up at something. Looking down is an angle of depression. Looking down is an angle of elevation. Also, this is really important, but we're going to write it down in the book or in the notes. Notice the angle of elevation is congruent to the angle of depression because they're alternate interior angles. So we have parallel lines with those horizontal lines. Parallel lines cut by the transversal, which is the way that they're looking at each other. So we have alt interior angles congruent. So that takes us way back. Parallel lines cut by transversal, alt interior angles are congruent. Here's our essential understanding. You can use the angles of elevation and depression as the acute angles of right triangles formed by a horizontal distance and a vertical height. So if you drop straight down perpendicular to the horizontal line, it forms a right angle. And let me just make that a little darker. There is a right triangle right here. And 38 degrees would be the acute angle. Or you could look at it this way too, going straight up. Here's your angle, and then there's the right angle. So we can use a right triangle formed by the horizontal distance and the vertical height. All right, so now let's go back to the notes. So go ahead and copy this. So we already looked in page 447, and I just wanted you to write down the key idea from there, which is the angle of elevation is congruent. Remember to pause if you ever need to the angle of depression because they are alternate interior angles. So I just did a quick sketch of what it was showing in the book on page 447. So I recommend you do that as well. We've got the hang glider, and I'm not a good artist, so I just kind of drew do the best you can. Just draw a hang glider and a little person. So if they're looking down at this person on the ground, but they're looking up at that person up there, then you've got your horizontal line from the hang glider, and you've got your horizontal line from the person on the ground. I guess I should show that they're on the ground. We've got that 38-degree angle of elevation and the 38-degree angle of depression. So again, the angle of depression is looking down, and the angle of elevation is, looking up like that. And they are congruent angles. They're both at 38 degrees. I'll go ahead and circle those just so that it's emphasized a little more. And again, because they are alternate interior angles, we have parallel lines cut by a transversal. All right, so again, pause if you need to. I'm going to go ahead and slide this up. And we have a couple of examples using the angle of elevation and the angle of depression. Whoops. Go ahead and copy those down. And then I'm going to complete them with you. So we're actually going to do some solving right now. There. All right, so what I have for the angle of elevation is a person on the ground. Remember, elevation means that they're going to look up, or whatever it is, it's looking up at that thing that's up in the sky. So I'm going to just use a ruler just so that it's a little bit better. So that's the degree of the gaze of how they're looking. And then we have the horizontal line right there. Okay. I want you guys to see, oh, I guess I can draw the other line too. I'll draw the horizontal line from the bird. You don't have to, but I'll just do it because that's kind of how that first example was. All that we need is one right triangle. So if I drop straight down from the bird and get that vertical height, and then the horizontal line, that makes a right angle. So then you guys can see it's a right triangle. Okay, so now I'm going to give you some information to complete that problem. And again, I'm not a good artist. This is just supposed to be a bird, like a seagull or something. Okay, so anyways, let's say that the angle of elevation is 20 degrees. And let's say that we know one more thing. So in order to figure this out, we need to know the angle, and we need to know one side of the triangle. So what I'm going to say is that I know that if you go straight down from the bird to the person, this is a distance of 90 feet. And what I want to know is how high up in the air it's not up from the ground, it's how high up from the gaze of the person's eyes, how high up from there is the bird. So I want you to think, what have we learned so far, especially from last week, about right triangles and when you know an angle and a side. So I want you to think of SOHCAHTOA. Oh, of course you can't see that. Okay, so think about SOHCAHTOA. This is trigonometry, of course. Trigonometry. So is it going to be a sine, cosine, or tangent? That's what I want you guys to be thinking. So the way you figure it out is I always circle the angle. So it's 20 degrees. And from the 20, I want to think what I know. There's two sides that we will be using. We don't have anything for the hypotenuse. So it's definitely not going to have an H. So I already know it's going to be tangent, but I'll just keep talking you guys through how you would know. From the 20 degrees, you look opposite. That's our O. And then adjacent is right there. So I would look and see which one has an O and an A. Only tangent, the TOA. There is no hypotenuse. So I would do tangent 20 equals, it's O over A, so opposite over adjacent, So x over 90. Okay, and then we just have to get our calculator and solve that. All right, so I'm grabbing my calculator. I'm going to zoom out so you can see the calculations. Okay, so I need to do tangent 20, and then it equals x times 90. So remember that I told you guys you could think about cross multiplying. Like that's over 1 cross multiply, or you could just think about multiplying by 90 to both sides. Oops, 90. That way it cancels. So there's more than one way to think about it, but either way I'm seeing I need to do tangent 20 and multiply times 90. So I could do tan 20, press equals on mine at least, and then times by 90. Okay, so that gives me x is approximately equal to, because I have to round it, 32 point. So it's 757. I'm going to round to the nearest hundredth on this one. So that would be rounding to the 5. But I look to the right, it's a 7, so I round up. So it's going to be 76. And then the last thing I want to do is make sure that that answer makes sense with my with like the situation. So would it make sense that if this bird is 90 feet away, like horizontally 90 feet away, like straight across, would it make sense that it's 32-ish, almost 33 feet above eye level? And yeah, that makes sense. If I got like a huge number, it may not make so much sense. Or if, of course, if somehow it came out to be negative or something like that, we would know that's wrong. But this answer makes sense. So just always ask yourself, does that answer make sense when you do get, when you do the calculation? Okay, so again, it was tangent 20 times 90, because you can cross multiply, or you could just think cancel out the denominator. That's division, and multiplication is the inverse operation. So you would multiply both sides by 90. All right, so now let's look at what the angle of depression would be like. So imagine there is a boat, and then there is I'm not good at drawing, a whale or a big fish. And let's go ahead and look at the information from this one. And then I'll tell you the situation. So we have a horizontal line from the boat. And horizontal line. Then we have the angle of depression from the boat to the fish, or shark, whale, dolphin, whatever you want it to be. So this is an angle of depression. And then we need to make it a triangle. So the way you would do that is straight up from there, we would draw a line like that. So the right angle is right there. It's perpendicular with the horizontal and the vertical lines. Okay, so on this one, I'm going to say this angle is 35. I'm trying to fit it in here. 35 degrees. And this time, let's say we know this side, and we'll try to solve for the hypotenuse. So let's say that this fish or shark or whatever is 30 feet. No, let's pick a different number. I'm just making these up. So they'll come out fine though. Let's say it's 40 feet below below the top of the water. So it's 40 feet below the top of the water. Looking from the boat down, the angle of depression is 35 degrees. Let's find out, like, if they were going to catch this shark or fish or whatever with fishing line, how long would that line be? Because it would go straight across from the boat to the fish or shark or whatever it is. Okay, so again, we're going to use SOHCAHTOA to solve. And like I always say, look at what we have given. This time we do have the hypotenuse. Always look from across from the right angle. That's the hypotenuse. So we do have that. So it's either sine or cosine. It really helps if you circle the angle and try to see what information do you have given. So I already said this is our hypotenuse, and then 40 is opposite. That's our O, and then adjacent was nothing. So if it has an O and an H, it's got to be the SO katoa, so sine. So in order to solve and find the distance straight across from the boat to the fish or shark or whatever it is, I can't draw. So whatever you want to imagine that is, the distance from there, like if they were going to catch it on a fishing line, we'd want to know how far is that distance. So we do sine, then the degrees, 35 equals, and then it's O over H, opposite over hypotenuse. So 40 over X. So from 35, 40 is your opposite, X is your hypotenuse. So before I start doing my calculations, I would want to isolate the variable. So if I cross multiply, I get X times, I guess I'll write it under, X times sine 35 equals 40 times 1, so 40. In order to get X alone, I then divide by sine 35, which you can do it. I know it's kind of weird, but just think of it as altogether, it's going to be one number. So it cancels out. And now we're going to start using the calculator. X equals 40 divided by sine 35. All right, so I'm going to go ahead and show the calculation on my phone. And remember, you could use the Desmos Scientific Calculator. I posted a link to that on our Power School. That always works. If you're not sure how to use your phone or the Chromebook calculator, you can just go online to the Desmos Calculator website. So anyways, I have to do 40 divided by sine 35. Sine 35. And that gives me this value. So I'm going to write it down. I'm going to round to the hundredths. So X is approximately equal to 69.7. I want to round to where the 3 is. The 7 after it rounds it up to a 4. And it's feet again. Okay, so real quick before I'm like, okay, I'm done, I want to make sure that that answer makes sense. So if this fish or shark or whatever is 40 feet under the water, and then the boat is over here, it has a 35-degree angle of depression, it does make sense that it's approximately 69 or 70 feet away from the boat. So that does make sense. Remember, the hypotenuse is always the longest side of a triangle, and so that does make sense because it is bigger. Okay, so we're going to do a few problems out of the book now just to practice. So get your book out again. And make sure you do include pictures of the book work when you turn in the notes this week. So make sure you guys are writing this down. The reason I really want to work out of the book is because they are word problems. They're like real life applications. So I didn't want you to have to write all this down in your notes. Okay, so here we are, page 449. We'll do a couple examples of angles of elevation and then a couple with the angle of depression. So this one, they drew it out for you, so you didn't have to do it. But imagine, as you're reading, imagine if they didn't give you the picture and you had to figure it out. It is kind of difficult. So try to see how we go from the word problem to the diagram. So it says you sight a rock climber on a cliff at a 32-degree angle of elevation. Your eye level is 6 feet above the ground, and you are 1,000 feet from the base of the cliff. What is the approximate height of the rock climber from the ground? So this one is going to be just a little bit different at the end. So make sure you're paying attention to how it's different from what we did in the notes. So it says what we have to find is what is the approximate height of the rock climber from the ground. Remember that this is your eye level and you're actually standing, and it says your eye level is 6 feet above the ground. So this distance is 6 feet. So from here to here is the ground. And of course, it's not drawn to scale because that's 1,000 feet, but I'm just showing it. So anyways, that's 6 feet. So what we need to find is that value of X, and then we'll be able to add in the 6 feet to get the height above ground level. So here's the climber up here. Like imagine a climber on the side of a rock or something, or a hill. So anyways, solving it like how we've done, circle the angle. It's 32 degrees. This is your opposite, and then this one is your adjacent. The hypotenuse, there's no value for it, so no hypotenuse. So thinking of SOHCAHTOA, all I have is O and A, so we're doing tangent. So I would do tan 32 equals, it's O over A, so opposite is X, over adjacent, which is 1,000. When I solve it to like actually get X alone, I would have to cross multiply or multiply both sides by 1,000. I like to just show that. And then that's what I need to do in my calculator. So I get the calculator and let's see if I can show it. It almost fits. There. Okay, so I'm going to do 1,000 times tan 32. The order doesn't matter. You could have done tangent 32 times 1,000. And we get X is approximately equal to, it doesn't say what to round to, so I'm just going to round to the tenths place, or I guess I'll do the hundredths, the tenths. I'll do the tenths. Approximately equal to 624.8. Look one to the right, it's a 6, so it rounds up. So 624.9 feet. I want to make sure that that makes sense for the situation. So if this is 1,000 feet from the base of the hill and then the climber's up 624, that makes sense. But it's asking what's the approximate height of the rock climber from the ground. So it's 624 from eye level, but add in 6 to get the height from the ground. So that would be 630.9 feet. So I would write it as, it's a word problem, it's a situation, so I want to make sure my answer is in words. So the climber is about 630.9 feet. I'll put from the ground. So again, the reason that I was saying this one's a little bit different is because we actually added in the height from the ground. The question could have asked, what is the approximate height of the rock climber from eye level? If it asked from eye level, it would have been the 624.9. But since it's saying from the ground and your eye level is 6 feet from the ground, we had to add in the 6 and we get 630.9. Okay, so that kind of took a while. Real quick, just to practice, the more we practice, the better. Let's just do number 3 real quick. So you can imagine again, like maybe this is a person looking up at an object, and then we've got an angle of elevation, and then we've got the given information. So always think SOHCAHTOA for our trigonometry. What I have is this angle of 20. This X is our opposite, 100 is our hypotenuse. So we have an O and H. O and H is sine. Sine 20 equals O over H. Opposite is X over hypotenuse 100. I hope you're getting the hang of this. The more times we do it, it should start making more sense. Multiply by 100 to both sides, or you could think of cross multiplying, and we just have to do this one calculation. Oh, it says round to the nearest tenth, so I do want to make sure I'm paying attention to that. So I get my calculator, and remember you can use the Desmos one. And we're going to do 100 times sine 20. And that would be 34 point. The tenths is where the 2 is, and there's a 0 after, so it stays as a 2. The units are feet. And this one's not a word problem. I don't know who's looking at what up in the sky, so I can't say like the climber is about, whatever. So your answer can just stay like that. Okay, pause if you need to. I'm going to go ahead and move on to the next page. And we're going to practice angle of depression. We'll do 2 problems here. Okay, so This first one has to do with an airplane pilot sights a life raft at a 26-degree angle of depression. So they don't have a picture, so I like to start drawing it so that I can see. So a life raft would be like a little raft on the water, and then there's like people there, save me. I don't know, I'm not good at drawing. So anyways, then here's the airplane. Something like that. Okay, so there's the airplane. And I'm going to use my ruler. Oh, where'd my ruler go? Okay, I don't have my ruler, so I'm just going to try to draw. So the pilot sights the life raft. So I'm going to draw a straight line from the airplane to the life raft, and then from the horizontal, right there, that is going to be my angle of depression right here, 26 degrees. And it does say that the plane's altitude is 3 kilometers. The altitude is how high up from the ground. So if I drop straight down at a perpendicular, so from my horizontal line, that's the horizontal, and then my vertical, that would be the 3 kilometers. Okay. Okay. So what is the plane's horizontal distance, d, from the raft? So I want you guys to think, which one's horizontal distance? This one or the hypotenuse, the slanted one? What is the horizontal distance? So it could be from the plane straight across before you drop down, or it could be the slanted one. And it would be this one. That's the horizontal distance. Oh, sorry, it's d. Since it said D, I want to make sure I put D. Okay, so anyways, that's how we sketch this. If anyone was like really good, they could have maybe visualized it, and just from the word problem, they could have maybe sketched this. I'm not though. I'm very visual. I have to think, where's the airplane? Where's the raft? I mean, they could have kind of thought about it that way. Here's the airplane. Whoops, that doesn't look like an airplane. Whatever. But anyways, I think it's better if you kind of just really draw the picture and think about how do you get that triangle from there. So anyways, to find this D, this horizontal distance, you have to look at the angle, 26. We don't have a hypotenuse given, so we have our O opposite and our A adjacent. So we will use, if you're thinking, so, ka, toa, if we only have the O and the A, that has to be tangent. So I'll write it out here. Tangent 26. So remember the angle always goes there. And then we have opposite over adjacent. Opposite was 3 kilometers over adjacent. That will be our variable D. And then we have to go ahead and solve. So you can think about cross multiplying or multiply both sides by D. We get D tan 26 equals 3. 3 times 1 is 3. Divide to get D alone. So divide by tangent 26. They cancel. And then I know I'm going to probably have to round. So I'm doing approximately equal to. Let's use the calculator and see what we get. Okay, so I kind of have to cover it a little bit. So 3 divided by tan 26. And I have to, does it say what to round to? What is the, okay, so I'll just round to the 10th place again. So it's approximately 6.15. That 5 rounds up, so 6.2. So approximately 6.2 kilometers. Oh, and since it's a word problem, I should probably write my answer with words. So the plane's horizontal distance from the raft is about plane's horizontal distance from the raft is, about 6.2 kilometers. Okay. All right, we're going to stop there. If you want, try number 5. Think about this x being right here, and then looking at this right triangle. So the way I drew it on the last one, I did that already, but I could have dropped it down right there and then said that this was 3 kilometers high. There's the right angle. Angle of elevation is the same as depression, so the 26 would have been there. And then you could have solved for D right there. So it's the same kind of thing. So looking from 27 degrees, we have this side, the hypotenuse, and we have that side. So if you want, give number 5 a try and see what you get. Okay? Make sure you do your questions and your summary, and these notes and book work are due at the end of the week.